The challenge problem says, a body of mass m moves in a horizontal direction such that at time t, its position is given by x of t is equal to a t to the fourth plus b t to the third plus ct, where a, b, and c are constants. And they want us to find a, the acceleration of the body, and b, the time-dependent force acting on the body. To solve this problem, we need to go back to the beginning of university physics, where we learned that velocity is equal to the change in x over the change in time, and where acceleration is equal to the change in velocity over the change in time. We also learned that we can use calculus to solve for velocity and acceleration, where velocity is equal to dx over dt and acceleration is equal to dv over dt. We can use these equations to solve first for velocity, then for acceleration. With velocity, we change our x to x of t, which also changes our v to v of t. And with acceleration, we change our v to v of t, which also changes our a to a of t. Now that we have our equations, we can start solving for acceleration. As we saw in the equation before, we need velocity in order to solve for acceleration, so let's find that first. We'll start by bringing back our velocity equation. Next, we'll plug our x of t into the equation. And now, to solve for velocity, we'll need to use some calculus and find the derivatives of a t to the fourth, b t to the third, and ct. For a t to the fourth, we can use the power rule to find its derivative, which gives us 4at to the third. For bt to the third, we can also use the power rule to find its derivative, which gives us 3bt squared. And for ct, again we can use the power rule, which gives us c. Now that we have our velocity, we can plug it into our acceleration equation. This gives us d dt times 4at to the third plus 3bt squared plus c. Now, we'll use calculus again to find their derivatives. We can use the power rule to find the derivatives of 4at to the third and 3bt squared, which give us 12at squared plus 6bt. And since the derivative of a constant is 0, our answer for part A would be a of t is equal to 12at squared plus 6bt. Now that we found our answer for part A, let's look at part B. For part B, they want us to find the time-dependent force acting on the body. To do this, we'll need to use our force equation from Newton's second law of motion, which states that the force acting on an object is equal to the object's mass times its acceleration. And like we said before, they want the time-dependent force, which means we would be looking for f of t. If you remember, in part A, when we changed our x to x of t, we also needed to change our v to v of t. This is because if we make our variable time-dependent, then our answer must also be time-dependent. And vice versa, if our answer is time-dependent, then one of our variables must also be time-dependent. In this case, we made our answer time-dependent, which means we need to see whether our mass or our acceleration is time-dependent. In Physics 1, we rarely have questions where mass is time-dependent, which means we can safely assume that our mass is constant. So if our mass isn't time-dependent, that means our acceleration must be time-dependent. And if you remember from part A, we were able to find a of t, which means we can now plug it into our f of t equation. And finally, by distributing our mass to 12at squared and 6bt, we have f of t equals 12mat squared plus 6mbt. And this is our answer for the time-dependent force acting on the body.